Hi everyone, I'm Mark, or you can call me Qiancheng. I'm a security engineer at Roblox. And today I'm happy to share our work Grimlock, which is our approach to securing high agency system with eBPF and Attested Channels. So this work is made possible by this amazing cross-functional team at Roblox. Wenhui is also here. So basically, I want to start this discussion by asking a question. So why do high agency systems require different security approach? So my take on this question is that high agency changes security because this system sits at the intersection of three risk factors. So first of all, as we all know, they consume untrusted inputs. This not only just includes user prompts, but it also include tool outputs, retrieved context, knowledge base, and messages from other agents. Second, they have this so-called dynamic execution. Basically, they decided at runtime which tools to call, which subtasks to spawn, and what to do next. Third, they often hold broad permissions and wide network access. After all, otherwise they would not be very useful. So in security, there's this old saying that for all the three things I talked about, if you have two, you are vulnerable. And guess what we have here? We have all three. And that's where our high agency system lands. So I would say the issue is not that agents are becoming so flexible and powerful. After all, we want them to be effective. I think the issue here is that because of this, security decisions often got pushed into the very layer that is the least stable and the least trusted, which is the agent application layer. For example, identity usually ends up here. Navigation ends up here. Even the orchestration code is basically orchestrated by the agents. And imagine tries to secure this system. This basically makes enforcement very inconsistent, very hard to audit, and most importantly, it's very easy to bypass. So the key idea we are arguing here is that we should actually let the agent keep their flexibility, but we must move the trust boundary into a guarded substrate that they cannot bypass. So from this, we divide three security goals. First, no bypass mediation. Second, channel-bound authorization. And three, least privilege delegation. So what is Grimlock exactly? So Grimlock is an eBPF-based host-level enforcement layer for high agency systems. It sits at the boundary of the sandbox and mediates communication before agents can directly reach the network. It restores the boundary in two steps. First, we use eBPF to intercept and mediate traffic at the sandbox boundary. So enforcement does not depend on the agent voluntarily doing the right thing to send the traffic. It's mandatory. Second, authorization is bound to the live secure channel after it's established. Basically, eBPF gives us mandatory mediation, and the attested channel binding gives us trust tied to the real communication channel, not just the app layer intents. So operationally, how does Grimlock work? Each agent will run in its own sandbox, and each agent will have a local guard, which is Grimlock. All sandbox traffic will be intercepted and redirected through that guard. And this agent does not get an unmanaged pass out. Then the agent talk to each other, the guards, Grimlock, talk to each other over a protected channel. Authorization happens only after the channel exists, and the plain text is released to the destination sandbox only after the checks are passed. So let me make this more concrete with a real agent-to-agent exchange example. So let's say, suppose we have two agents here, each running on different hosts. And we have Grimlock, or the guard, running on these hosts. So from the agent perspective, let's say if agent A wants to send a message to agent B, it's simply just an open connection as usual. But under the hood, at the sandbox boundary, this eBPF actually intercepts that flow and then redirects it through guard A. So right away, we see we get no bypass mediation. Guard A and guard B then establish a standard MTLS 1.3 channel. This is a standard MTLS handshake. And after that, we'll actually enable KTLS as a data plane here so that this path stays efficient in practice. Basically, now we will have one KTLS tunnel between the two guard agents. So once the secure tunnel is established, Grimlock now moves on to the attestation and authorization stage. First of all, guard A will send a request for the delegated communication, and then guard B will return the attestation evidence from its TEE trusted execution environment over that protected channel. Then, agent A is going to verify this evidence. So once this evidence is verified, a short-lived token, so-called scope token, will be minted. And this scope token does not authorize everything. It does not authorize the agent in general. It only authorizes this scope for this audience on this channel with this timing window. And then on the receiving side, the token and the channel bindings are validated before any plain text is finally released into agent B's sandbox. So basically, the guard B will validate the token, and then once it's validated, it will finally release the plain text data to the destination agent. So the key property here is that plain text is never released based on the application intent alone. It's released only after guarded channel-bound authorization succeeds. So what does this give us? It's very simple. Before Grimlock, trust lives in the app code, checks varies across runtimes, and then this delegation is broad and hard to audit. With Grimlock, it is possible for us to move trust into a guarded substrate, that mediation happens below the agent, and then delegation becomes short-lived, scoped, and auditable. So the takeaways here is this. So high agency is very valuable. However, it collapses security boundaries if trust lives in the agent application code. Grimlock restores that boundary with no bypass mediation at the sandbox edge and authorization bound to that live channel. The result is a practical model for secure agent-to-agent communication without asking the agent itself to become the security boundary. Yeah, that's it for the presentation. Happy for Q&A.
So it's mostly secure agent to agent. What about agent to the tool call, right, to extend our APIs?
Yes, very good question. So in this design, this agent, we will be able to cover the agent to external tool use. We will also be able to cover agent to, for example, web browse to external websites. Simply because this tool operates at the eBPF level, we are going to see intercept and see all the network requests. So it will be a generic solution. And the challenging part here is to whether, how you define the policy or the security strategy as to what to allow and what to deny. Yes, please.
I have the exact same question as you just mentioned. I always ask to all the rule-based system like this, how can you determine a policy for the agent to accomplish the task when you don't know how this task are going to be accomplished, because the agent is going to decide this. For example, in your example, what if agent A just say, I want to be the root and I want to access to all the files in your system, and how you this Grimlock are going to handle this?
Yes, I think this is a very good question. So the question is that without knowing the agent's intent, how are we going to define the security policy to accommodate that? So I feel like there's a natural tension here. So agentic system itself is actually non-deterministic, and the agent can decide to do a lot of stuff. My take on this is that from the security point of view, it's important to enforce a hard enforcement boundary. Basically, there will be a hard limitation saying that, for example, you could not be root. For example, there are resources that you are not allowed to access. This boundary, this requirement will be there regardless of your intent. As for the software, and this is something that I think will be suitable to be implemented at this layer. As for As for the other intents, like for example, accessing an internal tool, and this I agree, this will require a more flexible way to determine the policy.
Do you have any idea of how to roughly guess if it was okay?
Yes, this is actually a big problem facing the industry. We want the agent to be useful.